So I got cut off in that last video, so I just have a couple more minutes. As I was saying, I want to go over with you what an endothermic and an exothermic reaction are. Hopefully you've copied down the redox chemical reaction. Here are some examples for you, and we'll dive into that a little bit more. Remember, redox is when you talk about reduction and oxidation. Oil rig is the mnemonic device we used to remind ourselves when an electron is being given off or when it's being taken in. When you're gaining electrons or you're losing electrons. So that's what's happening in redox reactions. Endothermic reaction is one when energy is being absorbed. Exothermic reaction is when energy is being released. So as you have done your research, you run into these terms, so it's important that we go over them. Finally, last thing, when you were doing your research, I'm sure you ran into the term catalyst. So sometimes metals like nickel and aluminum are used as catalysts during steam reforming or gasification or maybe even electrolysis. But I've read about it more in steam reforming and gasification. So what is a catalyst? A catalyst increases the rate of the chemical reaction without going through permanent change itself. So for every reaction to take place, you need a certain amount of energy. So here's a graph I've shown you. Energy is on the y-axis, reactions is on the right, on the x-axis. So I've given you a key here. The dotted line is when no catalyst is being used. Solid line is when a catalyst is being used. So when no catalyst is being used, you need a high amount of energy for the reaction to take place and for you to switch from reactants to products. In the chemical reaction, when you go from reactants to products, you need a high amount of energy for that to occur. But when you use a catalyst, it lowers the amount of energy needed for the reaction to take place, so the reaction will take quicker. So now the energy needed is only this much compared to what it was prior. And I've shown you the differences over here. These are called the activation energies. So the activation energy with no catalyst is the max energy you needed compared to where you were when you were in the reactants stage. And when a catalyst is used, the activation energy is lower. And here's the activation energy when a catalyst is present. And remember, activation energy is the max energy compared to where you were in the reactants phase. So hopefully some of these terms have been familiar to you, or it's useful that I've gone over them with you in a little bit more detail. We'll continue this discussion. Please write down your questions from this video. Do a little bit more independent research. Some of the questions you'll be able to answer yourself. But write down questions that you may have for me and go ahead and submit them through our Dropbox. Thank you.